This is The Morning Show on WCIA3 News.
Physics professor Paul Kwiat is here to continue our lesson on magnetism.
Indeed.
Hey, how's it going?
Hey, nice to see you guys.
Great to see you.
So last time we talked cereal.
We did. We had Cheerios and milk, and we saw that when I had a magnet, I could pull them along, and that was because they have iron in them. And
Today's different, though. We got a
well,
grape.
today is iron. Today is different. Yeah, so we can talk about different materials that are magnetic, strongly attracted to magnets. But here I have a grape in water. Let me just get it so it's not right near the edge. And yeah, so we're doing lots of stuff with foods here, and we notice that the grape is actually pushed away by the magnet.
I
That's
can't
pretty
get over
cool.
this. Even your grapes.
Even grapes. And so that's because there are actually different ways that materials respond to magnets. In fact, if we call it the very first slide.
Here we go.
There we go. Great. So there's the normal things that you're used to. You might think of like this, like the metal nail, and those are strongly attracted to magnets, and so they create a magnetic field inside of them. And even if you take the magnet away, they can stay magnetic. Those are ferromagnets. That's like your garden variety kitchen magnet.
Yeah.
And then there are materials that are actually very weakly attracted to magnets. So there's only a magnetic field on them when the magnet is on, and when you take the magnet away, then they go away. So they're very weakly attracted. And then there are other things that are so-called diamagnetic, which means that they actually produce a magnetic field against the other one when the magnet is on. So it turns out water is a very common example of something that's diamagnetic. Okay, so if we come back to us now.
Boom.
Come back to us, great. And so let's just demonstrate that. So I have here
An island of sorts.
it's an island, and it just is a test tube that's just full of water.
Okay.
And we're just going to see that then this is also going to be pushed away from the magnet. And it doesn't matter which of the poles of the magnet you use, because no matter what, it's always going to be moving in opposition to it. So things that are diamagnetic are repelled in that case. And in fact, the most well-known example of that, and this was on my second slide, but I think it's on the bottom line that's not going to show up.
Oh, of course.
What? Is that it?
Yes,
No?
great. So it turns out that superconductors, if you can get them, if something is superconducting, it turns out it's a perfectly diamagnetic material.
So cool.
And so that means it's going to make a very strong field. So what I've done here, what I have here in this cup, I got to be a little careful.
Yeah, you do.
Because it's cold and it's frozen on.
Oh.
There we go. Okay, so this little disc is a superconductor. It will be when it's cold enough. And this little thing here is a magnet, and we just need to get that black disc a little bit colder so that it's actually superconducting.
I love it.
Okay.
Great.
Oh, whoop. We lost it.
And now I need to get that.
All right. While we're doing that.
Oh, I got it.
Perfect.
It's quick.
Okay.
And now, because it's completely repelled from the magnet, now it's just floating in space up there.
That is
That's
so
awesome.
cool.
It can blow away some of the rest of
heck?
some of the rest of the fog there. Okay, so none of the magnet field lines can go into the superconductor, so it's pushed away. So something like water
That's awesome.
is not a perfect
cool.
diamagnetic, so it doesn't have nearly as strong a force, but if you have a lot of water, it can nevertheless be affected a lot. And so there's this cool video that someone made of a frog in a very strong magnetic field, and frogs like us are mostly water. And so in the same way that the magnet was levitated here, the frog here is in levitation in this very, very strong magnetic field.
I don't know why it's so funny. That's great.
Indeed.
That is cool.
And people have done strawberries and other things like that.
I like the frog. Adds a little something.
Indeed.
Yes.
Okay, I think it's only 10 seconds. There we go.
It is. I repeated it for you just in case. Just in case you needed it. Cool, Paul. Well, I always learn something with you.
So I'm going to show just one more kind of common thing that's diamagnetic, which it turns out that carbon or graphite is diamagnetic. So this is just a little raft, and I've just put a bunch of pencil lead on it so people can do this at home. If you have a strong magnet, you can make a little sail, and you can use your magnet to sail away with the pushed away by the magnet.
Get out of here.
Get
That's
out.
cool.
Indeed.
I like it.
Cool.
Thanks, Paul.
Thanks, guys.
For sure. We'll be right back.